A severe threat is looming for the Ohio Valley towards the end of the week. Large hail, gusty winds, and a tornado or two are all possible. What's driving this threat? We got this disturbance coming down from the north here, and 500 millibar height falls showing up here, right? And that's where our area of interest is as well. This is 500 millibar height change previous 12 hours. You see this trough along this in this general area where our threat is, right? So as that trough and cold front moves through, we have showers of convection forming along this, right? So this is our time frame of interest in Friday, Thursday into Friday, right? We go Thursday, disturbance goes through and exits the East Coast. So when we move the 700 millibars, which is closer to the surface here, we can see what looks like a surface feature down here into central part of the continental U.S. During our time frame of interest, Thursday into Friday morning, right? We have our, this is 700 millibar flow, right? Maybe a surface type feature developing right along the lee side of the Rockies here, okay? Go down 850 millibars, which is a little bit closer to the surface. You see basically on here, right? Kind of this dip right there, okay? Some flow going like this, right? And coming up like this. So this trough is digging here, okay? And along to the east of this, and we have our, flow coming up this way, okay? That leads to convergence in this area, right? We go a little bit closer to the surface, all right? Let's do that here. And you can see how this evolves over time, right? So a little bit closer to the surface, 925, which is, you can see maybe what looks like a surface flow developing here, okay? Thursday into Friday. Not very pronounced, but definitely a dip in the jet stream on the lee side of the Rockies here. And along this boundary is where you would expect to see they have this convergence here. Okay, so pretty interesting setup with this. And, anywhere where you have enough instability and convergence, we could get storms, right? So we'll review that next in the next part of the forecast here. So looking at temperatures for the Ohio Valley for the severe weather possibilities, right? Plenty warm here, so we know the temperature's going to be all right. So as far as for severe weather, conducive for it. So what's the rest of parameters look like? So during our time frame of interest, right, we're looking at this the GPAS MPAS model, right? Sorry about that. This is a little bit of a longer range model that I'm using right now, just to kind of illustrate where the highest dew points are up to the north here. Okay, so these dew points in the 60s are definitely conducive for severe weather. So if this comes to pass, definitely one parameter here that is favorable for severe weather is these dew points. All right, and you see the dry air to the north of this is definitely, you see the cold air or dry air moving to the south here, not cold, right? But you see to the south here more warm air surging up to the north, right? Ahead of that front. Okay, so we got a surface low developing out west here. Moisture streaming up to the north, right over top. Looks like a more of a warm advection regime here. And right to the along that boundary is where the highest dew points are. As far as severe parameters, one thing we look at is updraft helicity, right? And this is pretty far out still, Thursday evening, right? And this can most be an overnight event, all right? But you see some rotating updrafts, at least according to this model, up here in parts of Indiana, Ohio, Illinois area, right? This is just one model. Doesn't necessarily mean this is going to happen exactly this way, all right? So we saw the other two parameters with the dew point and temperatures, right? Let's go back to the dew points real quick. You can see the dew points here along that area of interest are highest, right? Where we see where the spark of convection is and the highest the rotating updraft. So that's one look at it. Comparing it to the Rufus model, which is another short range, mid-range convecting allowing model, it tends to overdo things sometimes, but you could see the pretty much an agreement about the dew points. Kind of splotchy here, but in general agreement, right? And as we get through time, it moves to the south. What's the convection look like? So getting into the evening, right? You see the convection firing here. It wants to have some rotating storms in parts of, let's see, northern parts of Indiana, Ohio here, and surrounding areas. So really, this stuff won't be ramping up until the overnight hours. You see our initial push here, short wave or something moving through the flow, and another surge to the south here, right? And then we get into Friday morning, and this is where it ends up. So most of the severe weather, it looks like, is going to be focused in Ohio, Indiana, and Illinois at this point. So we'll see how this plays out, of course, but this is what it looks like from the two models that we can really look at. Now, there should be one more I can look at here real quick. Well, there's not a lot of other severe parameters that they want to show right now. We showed the two models and the possibilities. There's still a lot to work out as far as timing and whether convection will fire. So what we're going to look at now real quick is the flooding threat, right? If I can get this to load. This isn't load. All right, so you see going through time here, the heavy rainfall centered in the Ohio Valley as well. And accordingly, we have a day 3 excessive rainfall outlook showing a marginal risk for flooding in that area. So we have to be mindful of that as well as we get towards this period. And that's pretty much it. I want to just go over the severe threat, and that the only other thing we got going on is the excessive heat. And I think I'm going to make a separate video for that here and the pattern change coming up into the first part of April.